Hello, campers, rise and shine and put on your booties 'cause it's cold outside. That's right, it's cold outside. This ain't no Miami Beach. Hey, this is Mr. Zacek. If you know what movie that is from, write it down on your note sheet and I'll give you a little something in class when we go over it. All right, we're going to begin Circles Day 2. We're going to be talking about inscribed angles today, but we want to have a little warm up. And in our warm up, we want to remember what we talked about last time, and that was we talked about central angles. And a central angle, the key to the central angle is that its vertex is at the center, and a central angle is equal to the measure of the intercepted arc. So, intercepted arc. Those two are equal. And again, the key is the vertex. So as we look at our picture here, we have at the center of our circle, circle O, we have angle AOD is 70 degrees. So that tells us if we go to the ends of that, where does it intercept the circle? And that's arc AD, that the measure of arc AD is also going to be 70 degrees. So we got our first one here. Now we look, and what else do we know? Well, we see that we have a diameter here. And so I'm just going to use our highlighter here and note that this is a diameter, and a diameter cuts a circle in half, and therefore we can tell that this arc here, arc BD and arc AD, are going to add up to 180 degrees. So we would write the measure. My pen is not working. Of arc BD. Let me try that again. Okay. Oh, there it is. Okay, so we can tell that the measure of arc BD plus 70 is going to equal 180. When we subtract 70 from both sides, we're going to get the measure of arc BD. Now make sure that's not a segment notation, but that's an arc notation. So the measure of arc BD is 110 degrees. What do we know? Well, that is a arc, and here we have another central angle, and that's also going to be 110 degrees. So therefore, when we come over here to angle BOD, that will be 110. Those two are the same. And what's remaining? Arc ACB. Let me just use a different color here. Arc A starts at A through C to B. That's a semicircle. It's 180 degrees. And this is a straight angle as well. And so that will also be 180 degrees. So hopefully that gets us thinking back into what we've been talking about with angles. And now we're going to look at what we call an inscribed angle. And you see, an inscribed angle is an angle whose vertex is on the circle. That is the key. And we see it right here. Example, A, B, C. Now, the circle here, or this angle, the inscribed angle, angle ABC, we're interested in what arc does it intercept. So if you follow those out to those endpoints, it's going to intercept arc AC, and that's a minor arc in this instance. Okay, now our first theorem is that an inscribed angle is half of the intercepted arc and half of the corresponding central angle. So as we look at what we have here, an inscribed angle is half the intercepted arc and half of the corresponding central angle. So what do we see right here? The measure of angle ABC equals 1/2 the measure of arc AC. and the measure of angle ABC equals 1/2 the measure of angle AOC. That's the central angle. And related to that, the second theorem, an inscribed angle in a semicircle is a right angle. And that just follows along that when we have an inscribed angle in a semicircle is 180 degrees, a right angle is 90 degrees, and we can see here on our diagram, here's our inscribed angle. Again, the vertex is on. That's the key. Follow it. Where does it intercept the circle? Right there. So that arc is 180 degrees, and this is a right angle. Later on down the road, we're going to use that in some circle proofs. So this is a proof alert. They're coming, not right away, but just to be aware of that. We like to use that theorem because we get right angles and we can prove a lot of things with right angles. So initially what I just want to do is take a little time. Let's identify, do we have a central angle or an inscribed angle? And what I'd like you to do is just pause the video and fill those in. It should take you 30 seconds maybe. Okay, we're back. Let's just follow along and check. The first one here is a central angle. The vertex is at the center. The second one, the vertex is on. That is an inscribed angle. Number 3, vertex is at the center. That's a central angle. Down here, it's at the center. It is a central angle. Next one, on the circle, therefore we call that an inscribed angle. And the last one, vertex is on the circle, that's an inscribed angle. Now, just as a note, we're making an assumption here that those points are the center. We would need to be given some information that would tell us that, but in this case we're just making that assumption. So we have central angles, we have inscribed angles. All right, now for central angles, let's fill in the blank. Here again, why don't you pause the video, take 10 seconds, and fill in these two. Okay, welcome back. The first one, for the central angles, the measure of the angles is equal. Central angles, equal. For inscribed angles, the measure of the angle is half the size, the measure of the intercepted arc. All right, so again, central angles, vertex is at the center, inscribed on the circle. Example 1, here we have two angles, and I hope you can see that there. The arc here is 70 degrees, and that 70 is referring to this arc from here to here. Now, we see X is at the center, so central angle, intercepted arc, equal 70 degrees. Now, Y is this angle down here. Where is the vertex? The vertex is on. So when the vertex is on, we want to think half the arc. So the measure of angle Y equals 1/2. What's the arc that it intercepts? 70 degrees. And today we're going to start to see where that intercepted arc sometimes can be a little bit tricky for us. So the measure of angle Y, half of 70 is 35 degrees. So 35 degrees, what do they add up to? The sum of X and Y is 105 degrees. All right, let's look at example 2. Now, in example 2, sorry for that weird background color, but let's look at what we have here. Well, we have an arc, BE, that is 124 degrees, and we have an arc or an angle that is 50 degrees. This is a central angle. Now, there's different ways of approaching this. This picture is not drawn to scale. There's different ways of approaching this, but one of the ways is to work the outside of the circle in. So as we see here, across the center of this circle we have a diameter. Now the thing that we want to remember about our diameter, they cut the circle in half, and so we have 180 degrees. So that means that the measure of arc AE, okay, from A to E, put that in a different color along here, plus the measure of arc BE, that's 124, equals 180. So we subtract 124 from both sides, and that leaves us with 56 degrees, which is the measure of arc AE. What do we have going on up here? Well, we've got a central angle, and that's going to equal the arc that it intercepts. So how does that come out? It goes out like this. The arc CA is going to be 50 degrees. So again, we look here, measure of arc AC, CA, either way. You want to put those letters, it's okay. We have got 50 degrees. And then, as we look here at the top of our circle, again we see that we have a semicircle, which is going to be 180 degrees. So we're going to go and we'll say, well, that means the measure of arc BC plus 50 degrees equals 180. Now I know it doesn't look like it, these aren't drawn to scale, so sometimes that just helps us emphasize these things here. So subtract 50, we get 130 degrees. That's arc BC or CB. Again, you can name it either way. So now, as we're looking at our angles, I'm going to switch colors of my pen. I'm looking for the measure of angle A. Well, I look, where is A? Bad way to name it with just one letter, but A is referring to this angle here. It's on the circle. So A is going to be half of 124, half the intercepted arc. Half of 124 is 62 degrees. So the measure of angle A is 62. B is also on the circle. Here's angle B. Now you see where B is. Follow it out along the edges, and you see that it intercepts CA, our arc AC. So the measure of angle B is going to be half of 50, which is 25. And then finally, we have the measure of angle C. Oh, how are we going to get that? That looks a little tricky. Well, what we want to see is that this is a triangle that we have here. And so I've got this angle that we just found is 25, and my pen thickness here is going to kind of mess us up a little bit, so I'll do my best here on that. I'm going to just try to emphasize that triangle there. So we've got this angle here, B, is 25. Now, this angle that I'm highlighting right now, that's a central angle. That's going to be the same as that arc, which is going to be 130. And then angle C is the other angle in our triangle there, and so they add up to 180. So we're going to have the measure of angle C plus 130 plus 25 equals 180. Don't forget about that. Sum of the interior angles of a triangle is 180. So the measure of angle C plus 155 equals 180. We subtract 155 and we get 25 degrees. So you start to see how kind of the central angle and the inscribed angle, how we're putting those two things together. Okay, let's look at example 3 here now. Well, we have 4 things that we're looking for. And what we're looking for is arc 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. As we look first at the arc 1, we notice we've got the other 2 arcs along the circle. And we know that all the way around a circle is 360 degrees. So the measure of arc 1, seldom do we use numbers to measure arcs, but you know, it works here in this. So plus 90 plus 150 equals 360. So we combine like terms. The measure of arc 1, 90 plus 50 is 240 equals 360. And when we subtract 240 from 360, we get 120. So arc 1 is 120 degrees. Now we're going to move on to our angles. Next up, angle 2. Where is the vertex of angle 2? On the circle. Follow it out to the ends. What is the arc that angle 2 intercepts? It's 90 degrees. So the measure of angle 2 is going to be 1/2 of 90 degrees, which is 45 degrees. Next up on our list, we have angle 3. Again, where is the vertex of angle 3? On the circle. So follow it out to where does it intercept? And it intercepts this arc here of 150. So the measure of angle 3 is going to be 1/2 of 150 degrees, which is 75. And then our final one here on our list, see what kind of new color I can get for you, purple here, is angle 4. Angle 4, follow it out. Here's the endpoints where it hits the circle. What's that arc? 120. So 1/2 of 120 is 60. And if we were to add all of those inscribed angles up, they would equal 180. Now, a circle is 360, and an inscribed triangle is 1/2 of 360, 180. So we can notice some connections there in that, okay? And then arc 1 was 120 degrees. All right, we have one more example and then just a little summarizer that we're going to do here. In example 4, why don't you go ahead and do this, plus pause, do this. We'll come back and make sure you got it straight. Okay, we're back here. Again, we're looking for the measure of angle x. We notice the vertex is on the circle. Okay, it's on, therefore it's an inscribed angle. And I follow the rays out. What's that arc that it intercepts? 250. Again, probably not drawn to scale, but the measure of angle x is going to be 1/2 of the intercepted arc. So the measure of angle x is going to equal 125 degrees. Now, before we go on to that next one, I just want to add a couple ones in here that I didn't include in there first. And let's draw a circle here, and let's put in this circle an inscribed angle, and let's make sure we know how to work the other way. And so let's say that our angle here is, whoa, weird color, 80 degrees. I don't like that color. I'm going to draw it again. I think I had a highlighter on or something. Okay, 80 degrees. Now, that is an inscribed angle. So what happens when we want to go from the angle to the arc? What happens if we want to find Not looking for a crayon, I'm looking for the highlighter. Okay, this arc. That's okay there. Well, the arc is going to be, some of you already got it, twice the angle. So if I do 80 times 2, I get 160 degrees. We're going to do more practice with this in class here. So when you go from the angle, okay, angle to the arc, we want to double it. All right, so what are we going to do? And again, that's the inscribed angle to the arc, you double. Okay, so let's summarize that right here. Just as we're thinking about these last two lessons, the first thing you want to do is ask yourself, which type of angle is it that you have? Is it a central angle? I don't know if you can read that color clearly or not. Or is it an inscribed angle? So do we have a central angle or an inscribed angle? And then you have to ask yourself the question, are you looking for the angle or are you looking for the arc? Again, just so you can see that this is angle, I think you can see arc. Are you looking for the angle or are you looking for the arc in an inscribed? So this is central. Just want to make sure you can read that. This is inscribed. All right, well, central angle. It actually is equal, so the arc equals the angle. If we have the arc and we're finding the angle, the arc equals the angle. So that was before. Today, inscribed. Are you looking for the angle? If you're looking for the angle, you're going to, okay, divide by 2. Or multiply by 1/2. If you're looking for the arc, you're going to multiply by 2. So that gives us a little overview of inscribed angles.